So yesterday we have learned the HCF and LCM of two polynomials. Okay, so the technique of finding the HCF and LCM is to factorize the polynomials separately. Okay, and then we will compare the factors. For the HCF, we need to find the common factors. Okay, so if there is a factor which exists in both polynomials, then we will choose that factor, and then we will choose the smallest degree among the polynomials. Okay, and for the LCM, if a factor exists in any one of the polynomial, then we still need to choose it for the answer. Okay, and we need to choose the largest degree among the polynomial. So that is like this. Okay, and we have done example 4 at the end of the lesson yesterday. So I would like to do the instant drill number 4 with you together. Okay, in order to warm you up, and then I will ask you to do the exercise 9A, question number 24, 26, and then 33 and 34. So which will be in the Math app. Okay, in Math app. So let me paste the link to you. Okay. So instant drill number 4. ID4, you do not need to submit ID4 to the Math app. Just submit the other 4 classwork to the Math app. Okay. So Px is this polynomial. Part A, show that x plus 1 is a factor of Px. Okay. It is actually a question type in chapter 6. Okay, about the remainder theorem and factor theorem. So I need to show that x plus 1 is a factor of Px. So I need to calculate P negative 1, right? P negative 1, and I need to show that it is equal to 0. So I calculate P negative 1, and because we have the formula of Px, so we can really calculate P negative 1. Okay, like this. Okay, and it should be negative 3 plus 1 plus 3 minus 1 should be equal to 0. Okay, and remember to write down the conclusion. Therefore, x plus 1 is a factor of Px. Okay, so that is the first part of the solution of part A. And we also have the hence part. Hence, factorize Px. Okay, so Px is originally equal to 3x cubed plus x squared minus 3x minus 1. Okay, and we have already got the first factor, x plus 1. And then we may write down the second factor, okay, the long factor. So you may find the long factor by the long division, or you may use the faster method that I taught you during the lesson. So it should be 3x squared, and then it should be minus 1, and then the middle term should be minus 2x. Yes. Okay, just compare the x squared term. Okay, and don't forget to check whether the quadratic factor can be further factorized. Okay, in this case, I think it should be yes. So this one, 3x squared minus 2x minus 1 can be factorized to be x minus 1 times 3x plus 1. Okay, so if the question asks you to factorize Px, it really means that you have to factorize Px completely. Okay, so that is the answer of part A. Is that okay? And then part B, let Qx be another polynomial. If 3x plus 1 and this long polynomial are the HCF and LCM of PX and QX respectively. Find QX。好啦，嗱呢一個咧，咁就係我琴日臨尾咧所講嘅嗰樣嘢啦。So now we have two polynomials, PX and QX. Okay, two only, right? And then we have the HCF and LCM given. Okay, then we can set up an equation like this: PX times QX is equal to the HCF times the LCM. Okay, the product of the two original polynomials should be equal to the product of their HCF and their LCM. Okay, now among these four things, we have information on three of them. So we can use this relation to calculate the fourth one. That is the QX. Okay. Let's so PX is this. We have already factorized PX. So we use the result of part A. X plus 1 times x minus 1 times 3x plus 1, right? Okay, this is our PX. And then times QX. QX is the other polynomial that is unknown at this moment. And then it should be equal to the given HCF, that is 3x plus 1, times the LCM, that is 3x plus 1 times 3x minus 1 times x plus 1 times x minus 1. Okay? So, because everything is factorized, so you just cancel out the common factors carefully, right? So QX is equal to, so which one is cancelled? X plus 1, x minus 1 is cancelled. And then we also cancelled one of the 3x plus 1. So what is remaining is 3x plus 1 times 3x minus 1. Okay, so that is our QX. So you may expand the bracket or you may keep it in the factorized form. If you expand the bracket, it should be 9x squared minus 1. It's in the format of a plus b times a minus b, right? Okay, so that is the answer of QX of part B. Is that okay? 咁呢一個係用得嘅，呢一個啊，即係喺考試裏邊咧，呢一個係用得嘅，得唔得？雖然書係冇特別教嘅 ，OK， 但係當我哋需要用到嘅時候咧，係用得嘅，唔使 proof 啊，又唔使寫 reason 咁樣噶啦 ，OK， 得唔得 ？Alright, so now I would like you to do the following exercise. Exercise 9A, question number 24, 26, 33, and 34. I'll give you 10 minutes and then I will start talking about this. So please remember to upload to the Math app. Okay, so classwork. Exercise 9A, question number 24, 26, 33, and 34. 10 minutes. Okay, let's check the answers. So 24 and 26 are standard, I think. 24, we have fx and gx, okay, no unknowns. And fx is a quadratic polynomial and gx is a cubic polynomial, that is degree 3, okay? And part A, question asks you to factorize fx, okay? It is a quadratic polynomial, so you may just use the formula 1 to help you, okay? And then it is 2x plus 1 times 3x minus 1. And part B, question asks you to show that x plus 1 is a factor of gx. So you need to calculate g negative 1 and then to show that it is equal to 0 and to conclude that x plus 1 is a factor of gx. And then hence factorize gx. So you have the first factor, then you may use the long division to find the remaining factor, okay? And the remaining factor is quadratic, so you have to further factorize the quadratic factor into a product of two brackets. And when you find the two factors are identical, so please merge them to be a single factor and then power 2, okay, like this. And part C, to find the Hcf only, okay? So when fx and gx are both factorized, okay, then you may find the Hcf very easily. So that is the highest common factor, okay? So that is 3x minus 1. And then for 26, we have fx and gx, where fx is cubic and gx is quadratic. But we have an unknown k in fx. So we need an extra information in order to find the unknown k. And the extra information is that x plus 1 is a factor of fx, which means that f negative 1 should be equal to 0. So we find the f negative 1 ourselves and then put it to be 0. And then we can find that k is equal to negative 6. Okay, so this is the knowledge from chapter 6, remainder theorem and factor theorem. And then part B, we need to find the Hcf and Lcm of fx and gx. So fx has the first factor being x plus 1. So you may use the long division to find the remaining factor and then further factorize the remaining factor to be x plus 4 times x minus 2. And then gx is a quadratic polynomial. It can be easily factorized into x plus 1 times x plus 2. Okay, and then the Hcf and Lcm can be found very easily. Okay, so like this. Is there any problem up to now? And then I would like to talk about the remaining two questions, okay, more detailedly. Number 33. 嗱，今次咧呢題咧，第33題咧，就係佢即係調翻轉嚟問你啦，俾咗 Hcf 同埋 Lcm 你 ，OK， 跟住揾翻兩個 polynomial 裏邊嘅其中一個嚟嘅 ，OK， 即係咁樣。Number 33, the Hcf and Lcm. 抄過嚟先。Hcf and Lcm of two polynomials are x squared y and 3x cubed y squared z respectively. If the first polynomial is x squared y squared, find the second polynomial. 好啦，嗱呢一個咧，我會咁樣做嘅，咁都係放心啦。應該就唔會喺 long quad 裏面問嘅啦。咁所以咧，你只要個 concept 清晰 ，OK， 知道自己做緊咩嘅話咧，啲 steps 係唔重要嘅。OK， 不過咧，我都係即係盡量係detail 啲，去俾啲 step 你睇一睇咁樣樣。OK， 好啦，咁樣樣。First polynomial, we have second polynomial. Okay, and then we have our Hcf and we have our Lcm. OK， 嗱，我點解會分咁多格咧？咁就係我想即係分翻開每一個 factor。OK， so the Hcf and Hcf is x squared y, so it should be like this: x squared. The factor x has square, and then the factor y has power 1. Can you get this? This is Hcf. And then the Lcm, we have 3, that is to the power 1. And we have x cubed power 3. We have y squared, So that is power 2. And we have z to the power 1. Okay? And then for the first polynomial, it is x squared, y squared. So there is no number here. Okay? So we have x term and we have y squared. Sorry. Like this. 好，我將啲資料擺晒上呢個 table 嗰度先，好唔 OK？ 好啦，咁跟住咧，我哋會咁樣做咯。呢一度咧，即係個 first polynomial 係咪冇3呢個 factor 㗎？咁即係咧3嘅零次方咁樣去諗啊。OK？Z 都係一樣 ，Z to the power 0，because there is no factor Z here。Is that OK？ 好啦，跟住咧，咁我哋冇嗰啲都係填個0啊。個 Hcf 亦都係一樣。OK？Z to the power 0， 填翻密佢咁解嘅啫。好啦，跟住咧 second polynomial 呢4格，我哋就咁樣啦。3 to the power A，x to the power B，y to the power C，and z to the power D。OK， 我咁樣擺出嚟先，得唔得？我解釋俾你聽就咁寫嘅啫，得唔得？咁當然對諗嘅時候咧，其實好快搞掂嘅。OK， 好啦，咁而家即係咩意思咧？即係話咧，嗱，而家係呢兩個 polynomial， 我哋逐行睇，即係逐棟睇啊。3呢一棟，我哋有0同埋 A 係咪？0同埋 A， 我哋咧係要個 minimum 係等於0 ，maximum 係等於1。OK，among (0) and A, we need the minimum equals 0 and maximum equals 1. Because Hcf is choosing the minimum degree and L.C.M is choosing the maximum degree. So now, minimum is 0, that is okay. But I need the maximum to be 1, which means that A should be equal to 1. Can you get this? And then for the second column, among the index 2 and B, I need the minimum to be 2 and the maximum to be 3. Okay, now minimum is 2 and that is okay, but the maximum should be 3, which means that B should be equal to 3. Okay, and then among 2 and C, I need the minimum to be 1 and maximum to be 2. The maximum is here, but the minimum should be 1, which means that C should be equal to 1. Okay, for the fourth column, among 0 and D, I need the minimum to be 0 and the maximum to be 1. Okay, the minimum is here already, but we do not have the maximum. So the unknown D should be equal to the maximum, that is 1. Which means that the second polynomial should be equal to 3 to the power 1 times x to the power 3 times c to the power, y to the power 1 times z to the power 1. Okay, so that should be 3x cubed yz. OK， 得唔得？逐行去睇嘅，諗嘅時候咧，其實都係咁樣諗嘅，只不過你唔使寫出嚟咁解嘅啫。好唔 OK？ 好，呢度得唔得 ？get 唔 get 到？ get 唔到嘅話咧，我哋聽日翻嚟咧再講埋第34條啊。好唔 OK？ 得唔得？ So if there is no more problem, then that's the end of this lesson, and you may leave now. Goodbye.